Hello everyone, myself Alok Kumar. I am Assistant Professor in Government College of Engineering, Dharmapuri. So here we will see third unit of compiler design, that is intermediate code generation. In this lecture we will see SDD, that is syntax directed definition, and with the help of examples here we will see and what are the different attributes that also we will see, that is synthesized and inherited attributes. Okay, so now let's begin. Let us start. Syntax directed definitions. So a syntax directed definition, SDD, is a context free grammar together with attributes and semantic rules. Attributes are associated with grammar symbols and semantic rules are associated with production rules. Suppose we are saying if capital X is a symbol and small a is one of its attributes, then we write x dot a to denote the value of a at particular parse-tree node labeled x. Okay, so evaluation of these semantic rules may generate intermediate codes. It may put information into the symbol table. It may perform type checking. It may issue error messages. Okay, so here we can say there are two ways to represent the semantic rules associated with grammar symbols. First, we can say like syntax directed definitions, SDD, and the second one is syntax directed translation schemes, SDT. So here we will see, in this lecture we will see SDD. Next lecture we will see SDT also. So SDD, syntax directed definition, we can define this one. A syntax directed definition is a context free grammar together with attributes and rules, production rules. Attributes are associated with grammar symbols and rules are associated with production. Okay, suppose here you can see this one is the production rule. E is generating E plus T. So semantic rule we can write E dot value. Suppose VAL is one attribute of capital E. So we can write E dot VAL equals to E dot val plus T dot val, where this E1, why we have written, so that we can differentiate from left and right. Okay, so in actual this one is same, but for differentiating we are writing this one as E1 dot val. So like this way we can define like syntax directed translation schemes. SDT embeds program fragments called semantic actions within production bodies. The position of semantic action in a production body determines the order in which the action is executed. Suppose for example E is generating firstly this rule is there, action is there, whatever we are performing, print plus, and after that this one is E plus T. Okay, so like this manner, suppose we can write this SDT. How we will write this one also we will see with the help of one example in further lecture. Here we will see firstly SDD. So suppose here we are having some production rules are there, and based on that we are writing here semantic rules also associated with that. So we will say this one as SDD, syntax directed definition. Suppose here L is generating E and here N is the end marker. Why we are writing here this N? So that we can check whether the input string is passed or not. So okay, so with the help of this N we can check, yeah, if when we are scanning, when we are parsing, and if input is reaching up to last, so we can say this string has been passed. So this semantic rule we are writing L dot val equals to E dot value, and E is generating E plus T, so E dot value equals to E1 E plus E value plus T dot val. Here third production rule is E is generating T, so E dot VAL equals to T dot VAL, where VAL is attribute of E also and T also. T is generating T1 T asterisk F. So here we can write semantic rule like T dot value equals to T1 dot val into F dot value. T is generating F, so we can write T dot value equals to F dot value. F is generating opening parenthesis E, closing parenthesis, so F dot value we can write semantic rule like this manner, e dot value. F is generating digit, so f dot value equals to digit dot lex value. So here we can say in this SDD, each of the non-terminal has a single synthesized attributes called VAL. What is synthesized, that also we will see. So we also suppose that the terminal digit, this one, has a synthesized attribute lex value, which is an integer value returned by the lexical analyzer. Okay, so this one is example of syntax directed definition. Now here we can see what are the different types of attributes. Attributes may be of two types. One is synthesized attribute. A synthesized attribute for a non-terminal capital A at a parse-tree node n is defined by a semantic rule associated with a production rule at n. Note that the production must have capital A as its head, or we can say root node. The attribute can take value only from its children variables in RHS right hand side of the production. Suppose here we are having one production rule, E is generating E plus T. E1, why we have written, so that we can differentiate with this E. This one is left side and this one is right. So E, we can write semantic rule E dot value equals to E dot val plus T dot value. So this one we will say as synthesized attribute. VAL is a synthesized attribute. So at every node n labeled capital E, this one root node, okay, with children corresponding to the body of its production, the synthesized attribute VAL at n, means we are saying for root node capital E, is computed using the values of VAL at the two children labeled E and T. Okay, these are two children of this capital E. So now here we can see the second attribute, that is inherited attributes. So we can define this one, and inherited attributes for a non-terminal capital B at a parse-tree node capital N is defined by a semantic rule associated with the production at the parent of N. Note that the production must have B as a symbol in its body. Okay, this one definition we can clear here with the help of this example. The attribute can take value either from its parent or from its siblings. So suppose we are having one production rule, A is generating XYZ. So we can write production rule, the semantic rule like this manner. Suppose Y dot S, where S is the attribute of Y, equals to A dot S, means we are finding the value of this one with the help of its parent or its children. Okay, so suppose Y dot S, here we are finding with the help of its children, X dot S. So this one we will say as inherited attribute. Here S is an inherited attribute. So here Y's attribute value is depending on A's. A is parent of Y, and capital X, that is the sibling of Y. Okay, so this is the example of inherited attributes. Okay, so like this manner we can say in inherited attributes, attribute can take value either from its parent or from its siblings. Okay, so now we will see how we can evaluate an SDD at the nodes of a parse tree. Okay, so a parse tree showing the values of its attribute is called an annotated parse tree. With synthesized attribute, we can evaluate attributes in any bottom-up order, such as that of a post-order traversal of the parse tree. Suppose we are having one SDD here and we are evaluating this string 3 into 5 plus 4, and here this n is the end marker. Okay, so suppose we are taking the same SDD, whatever we have taken in previous, I have shown you here. So here we can see this SDD and we will evaluate this input. Okay, so how we can evaluate? So for that we can construct parse tree, and parse tree, after constructing parse tree, we have to make this one as annotated parse tree, means at root node or whatever node is there at that time, at that place, we have to write the value of that node. Okay, so we can construct, if we are finding this one, we are having one input string 3 into 5 plus 4, so we can construct parse tree. So we can construct using this these production rule. L is generating capital E, L is generating capital E, after that E is generating E plus T, After that T is generating T and T is generating T into F. After that T is generating F, F is generating digit like this manner, and here F is generating this digit. Here T is generating F, F is generating digit. So like this manner we have to find the value at each node. So digit, this one is digit, so digit dot lex value, like this manner we can find. So value will be 3 because this one is 3 into 5 plus 4, so we can find 3 and this value will become 3 because we are finding the value of this one from its children. Okay, so this one will become 3. We can see these semantic rules. So T dot value will become this F dot value, that will be 3. After that here this 5 is 5. Here asterisk, here we can find T into F, so T into F like this manner. So here it will become 3 into 5, that is 15. Here 4, 4, here 4 will come. So this one is 15 because of this one is generating T, this value. So 15 plus 4 it will become because of this semantic rule. So here it will become 19. So 19, this value here like this manner we can write. So this one will become the value. Okay, so this is the example of this SDD, means how we can evaluate a string. Okay, so remaining example we will see in next lecture. Thank you.